Okay, here we have three graphs from three different spectroscopic techniques. We've got Mass Spec, carbon-13, NMR, and IR. We're going to look at these graphs to identify the unknown molecule. If we look at the Mass Spec graph here, we can see that there is a peak furthest to the right at 88 mZ. That's going to mean that the molecule has a molar mass of 88 grams per mole. We see there is a peak here at 43. That is most likely from a fragment. Here, that is 3 carbons in a row. And then we have a peak at 29 that is from the 2-carbon fragment, or 2 carbons and 5 hydrogens. We also recognize that there are no n+1 to n+2 peaks in the ratio of 1 to 1 or 3 to 1, so there is no bromine or chlorines present in this molecule. If we go to the carbon-13 NMR graph, we can see that there are 4 unique carbons. There are distinct peaks, so there are 4 unique carbon environments. If we go and look at the peak on the left, we can see that there is it's a peak at 171, which is in the range of a carbonyl group. There is also another peak here at 61 that's distinctive. It's going to be a carbon single bond oxygen, and we have these other peaks here that are just going to be carbons bonded to other carbons and hydrogens. Okay, if we go back down and look at our IR graph, we can see that there is this distinctive peak at 1740 centimeters -1. That is, of course, going to be our carbonyl group produced from the C double bond O stretch, and then we get the C to H stretch producing this peak at 3000. If we put all of this together, we are going to know that we have this fragment of 3 carbons in a row. They have to be in a row because we have to have 4 unique carbon environments. We have an oxygen joined to a carbon, remember, from our 61 peak in the NMR graph, and we have our carbonyl group on the end. So this is the molecule. It meets all the requirements. Here is our 171 peak, our 61 peak, and our 21 and 13 peaks in the NMR. So this molecule is propyl methanoate. Good luck with your next